This is Lab 2 for Physics 2, the charge tapes continue. So this lab is a continuation of the same concepts from Lab 1, exploring interactions of charged strips of tape with the environment as well as each other. And so it's differentiated by modeling the strips of tapes as lines of charges instead of a single point charge. Fundamental concepts used were Coulomb's law, electric fields of distributed charges, and gravity. And the electric field due to a charged rod where length is a lot greater than separation distance is K times 2Q over L all divided by R. And my results, the tape had a positive charge and Q was found to be 1.8841 times 10 to the negative 8 coulombs. And the diagrams on the left show how the lab was performed, like in Lab 1. So to accomplish a charge on the tape, one piece was pressed flat on a surface and another laid directly on top of it and rapidly pulled off to give it its charge. In the other diagram, the two tapes, which are assumed to have equal charges, were shown with the top one being repelled by the bottom one from the starting position. So some data and measurements. Both the tapes had length of 8 inches, which is 0.2032 meters, and the mass was found to be 2.032 times 10 to the negative 4 kilograms. And so in Lab 1, my values for the separation distance I think were a little bit off, so I reperformed the lab and got a new separation distance of 1.49 centimeters, which is 0.0149 meters. And then the force of gravity on the top tape is 0.0019934 newtons, and the electric force on the top tape from the bottom tape, which I found using my code, was 0.001993339 newtons. And so we used the same electric field function from Lab 1, and I represented the tapes as lines of 10 point charges with iteration. And with iteration, I was able to find the electric force at each point on the top tape. And the total electric force on the top tape by the bottom tape was also found using iteration, with the number of point charges increasing. And so this is the first page of code, and the second. And here you can see some of the modeling, or code for the modeling. And finally, the model shown. And so the white arrow in the model represents the total electric force on the top tape, and the yellow arrow represents the gravitational force on the top tape. The green arrows represent the electric field at each of the 10 point charges that represent the top tape. And so when Q equals 1.8841 times 10 to the negative 8 coulombs, the magnitudes of the electric force and gravitational force are extremely close, as you can see. So some results and assumptions. That was my Q value that I just stated, and my assumptions were negligible air resistance and that the charge was evenly distributed along the length of the tape. And so in conclusion, here are the two questions posed. So in the previous lab, we modeled the tapes as single point charges, and so we were going to compare the two values. So after inputting my new separation distance of 1.49 centimeters into my code for Lab 1, I found Q to be 7.017 times 10 to the negative 9 coulombs. And in this lab, Q was found to be 1.8841 times 10 to the negative 8 coulombs, which the difference in the order of 10, because the first one had 10 to the negative 9 and this new one has 10 to the negative 8, is a significant amount. And so why the two computational values being so different, and why they are different, and which value is more likely to be closer to the actual value. So they're different because in estimating point charges, the electric force points directly up, while in distributed charges, there are horizontal as well as vertical components. So more charge is needed to ensure that the vertical component has enough magnitude to cancel out the force of gravity. And personally, I think that the distributed charge is more closer to the real value, just because in charged objects, the odds of an object having all of its charge concentrated at the middle of it, pointing directly up, doesn't seem very likely to me. And just overall, in conclusion, the coding on this lab was definitely more challenging. But yeah, thank you for listening, and goodbye.